Falsifiability is incredibly important to the scientific world. The basic idea of falsifiability is that something can be proven false under the right circumstances. So here, let's use an example. You're watching this video right now. This is falsifiable and can be proven false if you weren't watching this video right now. But since you are watching this video right now, it is proven true. Let's try another example. This is a bottle of water, but I'm gonna call it a bottle of milk. This statement is falsifiable and is proven false because by basic observation, we can determine that this is a bottle of water, not a bottle of milk. Falsifiability is very important because if you have something that can be, under the right circumstances, proven false, then under the right circumstances, it can also be proven true. And if there's no way to prove that something is false, then there's also no way to prove that that something is true. That explanation might be a little bit confusing, so let me break it down with an example. I'm going to make an unfalsifiable claim, and I'm not going to tell you if it's true or not. There is a sentient meatball the size of the moon right next to the Earth, but it cannot be detected because it's in another dimension. You can't prove that is not true, and I can't prove that that is true. Here's what's funny about this claim. You cannot say with 100% certainty that this is false because there's no way for you to determine that it's false. Just like there's no way for me to prove that it's true. Now, if we had some type of sci-fi extra-dimensional goggles that could see into another dimension, then maybe we could use that as a way to disprove or prove this idea of the giant sentient meatball in another dimension. But we don't have that, and we have no way of determining for certain that this giant sentient meatball doesn't exist. Now, you might be looking at me and thinking, but you clearly made it up. So that alone proves that it's not true. I didn't say if it was true or not. I'm just making a claim. So there's no way for you to say for certain that I'm lying. To be honest, you can basically make up any idea and use the whole beyond this reality concept, and it becomes impossible to disprove. So here's a good example. I'm standing right behind you right now, but I am an invisible ghost. You can't prove that's not true. There are scientific theories and ideas that have been put forward that are not falsifiable by observational means. One good example is string theory. I'm not going to go too much into detail about what string theory is, but the basic premise is that throughout the entire universe, all the fundamental particles and forces are actually tiny one-dimensional strings vibrating at certain frequencies to where it creates what we observe to be the fundamental particles and the fundamental forces. There's no way to prove this or disprove this through observation. There's absolutely no way. The only reason why it still holds up to this day is mostly due to mathematics. It has passed some mathematical tests. And for this reason, some researchers think that, hey, maybe there is a way to test it, but we have to find the way to test it. But as of right now, we have no way to test it. So in the end, when it comes to observation, string theory is unfalsifiable, and it will remain unfalsifiable until scientists find a way to falsify it. And until they find a way to falsify it, there's not much that can be done with string theory. Something being unfalsifiable doesn't automatically mean that it's untrue, and it also doesn't automatically mean that it's deceitful. But until a time comes where it is falsifiable, this thing should be seen as more of an idea rather than an actual scientific concept. Falsifiability is very important for progressing our knowledge of the universe, and it's very important when trying to avoid falling into logical fallacies. We're all bound to get information wrong at some point or present a flawed view of how things are. One of the reasons why I say at the end of many of these videos to never be afraid to ask questions is because it's important to question not only the statements of others, but your own statements about the nature of the universe. When a statement is spoken, ask these questions. Does this information and the method for understanding this information make sense? Is this information backed up by reliable sources of evidence? And is this claim falsifiable, and how can it be improved?